Switch this around. There we go. Got it all set. Now, I just need to figure out share. And copy link.
We're on our way to New York, New York, New York.
Nice. Very nice.
She has a really strong voice.
Very nice. I like it.
Way up in her 90s.
Here we go.
95.
I used to sing, I lived in a little town in North Carolina. Oh, well, thank you.
You've got a great voice.
Anyway, I lived in a small town in North Carolina. Every day, was passed back to go into town. And come out from the bank with me. And I said, what are you going to sing to me today? And I said, what would you name? And I said, 5'2", eyes of blue. Could she could. Has anybody seen my gal? And if you want running to, that's all. That's the words. Oh, God of mine. That's the rest of it. Oh, no, we'll have to get you. That would be nice. Yeah, well, that's enough of it. But anyway, I was the entertainer is in North Carolina, in Northampton County, and I had red hair then, and I still have.
Good, Elsie.
Can't do it there. I need a better shot.
And my mother said, dear God, please don't get them in. Because my mother never did love me, don't like me, because I never had. It's true, I swear ever since I was
Leave this right here.
Okay.
Right there for a second.
Does he mean I can't sit there?
No, you can't sit
Me
there.
too.
If you're going to get a seat, you better sit down.
Sit right here? Okay.
Go sit down, Elsie, so you get a seat. You may not get one if you don't.
You are the promise that makes the lonely winter seem long. I did my work.
You made it up.
No, it's a really a song. And then, what is it? You are the promise that makes the lonely winter
Oh, yeah.
seem
She
long.
sings Bring Up New York, she gets real loud.
Start spreading.
Here we go. Sit down, Elsie.
Start spreading the news.
Sit down, Elsie.
Okay,
Sit down, stop.
you don't have to ask me again, I'll sit
You're
there.
doing great.
Yes,
Super.
You just say bless you and go on. Don't bother us. We have them too. You do. I can't even look like no problem. I bet my room, I will start soon. I did 10 times and then quit.
My eyes have been watering. I think I'm here in my line.
well, they shouldn't have parked there because it's in the way, it's in the way there.
Okay, got that.
Checking where, see where you are. Right, you are. Hello, Mr. Frank.
Hey, Cliff.
Don't let nobody get by you.
Be careful.
Come, hey, let us slip down, you come over here, sit beside us. No, they can sit right here beside you and you'll be all right. We move
I'm
down.
worried about people walking around.
There's only a couple of chairs, they can get
I'm
around
worried,
that way.
Frank, I'm worried about people walking across that floor.
Ah,
Because they can't, they have to go that way. Yeah, we were. Yeah, that's good.
Good driving.
No, honey, don't move them. You can't sit in these two chairs.
He saved this for me.
No.
This is my seat.
Oh, okay. All right. Well, I was told not to let anybody sit there, so that was for you. Is that your son?
No, it's my daughter's sister's son.
Okay, you're the one that brought him in.
No.
That's right. May as well come down.
He came from Spain. And this, he picked the best time in the world.
watch the wires.
Be careful, honey.
Is that champion me?
Yeah, you can't sit there.
Oh, yeah, get ahead. Go ahead.
Yeah.
Get right here.
Yeah. No, I want to sit on a chair with arms.
Where do you want to go?
The chair with arms right
You want to
behind
sit
me.
there?
Right there.
Where do you want to sit?
Right there.
You want to sit there?
So I have to.
No,
All right, I'll get you.
Okay.
My son.
Oh, this was.
well, okay.
These are for you. These are for you, Mom.
You didn't tell me.
I'm so sorry. This is my mom, so.
Don't let anybody sit, no.
She's doing her job, isn't she?
Well,
We can cut this off. I'm done with that now.
you didn't tell me he had special people.
No, Mom?
Just his mom.
Now, that, you just have to hold it
Coming down early.
like that.
Okay. Go aim it at your face. Is that what I'm going to
Well, you're gonna just follow me around with it. Like that.
follow you around
Just
with
follow
it?
me,
I'll
okay.
hit
Really?
a
What
go
you wanna-
button.
No, you don't do anything. It's already done.
See, I don't know much about this stuff.
Just don't do anything.
I need you to tell me Phil's phone number.
You can't go anywhere.
348
226-348-6943.
6943. Uh-huh.
Yeah, but be sure you caution them about this cord if they come across.
I'm sorry?
What's his
I'm
name?
Richard.
Richard, they call him
But I'm
Richard.
checking with Phil to see if he can sit. I sent him the link.
I want him to be sure.
I'll tell him.
Give me, Mom, give me another phone
Worry
number.
about
Send
the
this, for
cord.
example.
697,
326-697.
691.
697.
What did I say? 169.
169.
Wait a minute. I've got it.
When people are crossing over here,
I know, Mom, but I don't have a choice right now.
we'll just remind them. I mean,
sure.
caution them.
Sure, sure.
What do they have to do to get this? My family, none of my family can come and see this.
I know, because they're all snowed
Uh-huh.
in, he said.
Yeah, it's pretty snow though, isn't it?
Oh, it's beautiful.
It was snowing like this on my wedding day.
Was it?
Exactly.
I'll be
Yes.
darned. What day were you married?
January 28th.
Okay. Watch your mom. Okay.
Here it is.
How you doing, Ward?
I'm anxious to see this myself.
You haven't seen it yet?
No, he started doing this in Spain
Uh-huh.
at the school that he was at.
Uh-huh.
Yeah, we got Phil.
And then by word of mouth, other schools heard about it
Oh, yeah.
and called to see if he would come and do the presentation there. Then somehow the adults got involved and he was putting it on for adults. So I haven't seen it. I just know.
Well, I love any travel photo, or anything about, I watch all of the travel shows on PBS.
Yeah, I know.
I love them.
I do too. And
336.
actually, his wife couldn't come with him because she's in school, and so she couldn't come with him. But she's dying because she wants to see the snow.
Do me a favor, check your email. There's a link that I sent you into it. Click on that email and see if you can see what I sent you. I'm broadcasting live, so maybe you guys can see the presentation.
Tell him to call.
Okay.
Yeah, but he's gonna lecture.
Maybe it's a big blob of ice.
Yeah, I am. Can you point it, see what no, turn sideways. Yeah, turn sideways.
What's you?
Just like that. That's all you need.
Oh, I see.
Just put it to make sure that they can see the TV.
Oh, the TV.
And you see, Mom, you have a really bad habit. Like that, just like that.
Let me have it. Careful. See, it's got to be up like this.
Let me see.
That's hard to hold up on.
You got it? So you can see the audience now? Okay. Okay, so, all right, it's gonna be a little delayed, but you should be able to see it, okay? And I sent that to Helen. Can you call Helen for me?
And
Tell her I sent her the link. And tell Tommy that I sent him the link. So if you just use that link, you should be able to watch the presentation. I don't know, the Wi-Fi here is for streaming, obviously it's not set up for that. So it might cut out, at least it's something, okay? Okay?
That's hard to hold up the whole time.
I got my arm resting on the. We were just trying to do something to get our family because so many of them wanted to come and they live outside of Greensboro.
I see cars whizzing up and down in the front of the house.
Well, they say Battleground is not very good,
Oh, no, of course it's not. People are still out.
and people are stupid.
They are stupid, you're right, Dora. In spite of the fact they've been on 24 hours begging people not
I,
to go out.
I know.
People don't listen.
Okay, what time is it?
It's,
Y'all wanna get started, or should we wait 5 more minutes to see if anybody else shows up? All right, we'll do that.
So we can get in on nap.
Okay.
then
Yeah, I gotta have nap time, right?
Yes,
Okay.
I do.
Well, as you guys already know, I'm here visiting my mom. My name is Richard Owens, and I live overseas. I'm just in town for a week and visiting her, and thought we'd have a little time to share my experiences. I used to work at a base in, two bases, research bases in Antarctica, okay? I worked at McMurdo Station as well as the South Pole. And so this presentation is kind of just basically my personal stories and about my experiences down there. And you can see firsthand what it's like to live and work in Antarctica. All right?
yeah.
So, to kind of get you a little idea about the size of Antarctica, if you overlay it across the United States, you can kind of get an idea about how enormous it really is, right? And we all know, I mean, what's the difference, the main difference between the South Pole and the North Pole?
One's north and one's south.
Well, yeah. South is a continent, right?
Yes.
The north is just ocean, okay?
Right.
And I'll show you later a cutout of how the continent is actually underneath the ice, okay? Well, let's take you on a trip. How do we get to Antarctica to begin with, right? It's a long trip. It's not just like flying across the United States.
Right.
So the company that I worked for has the government contract with the National Science Foundation to provide support staff to all the scientists. I myself am not a scientist. I just supported their work, and me with thousands of other people really helped their programs. So what do? The scientists put together a grant package study package that they want to study a particular thing, either the volcanoes, the biology, or the glaciers, or whatever, and they present that to the National Science Foundation, and they approve or don't the grant. And from there, they put together a team, and then the National Science Foundation funds everything. So all they have to do is worry about taking their team, going down, and doing their research, and then bringing it back to their respective universities, and they can go forward with the research. There are scientists that have actually been doing studies, continuous studies down there for over 30 years.
Wow.
Go back down there every season, all right? So what do? We come from all over the United States. Grab a flight, we go to Los Angeles, okay? From there, we leave the United States and head down to Antarctica. I put together a little Google Earth video to kind of show you I normally do this presentation from Barcelona, so I show the trip actually from where I live. This is where I live overseas. And so we fly from Barcelona, okay? So then I start the real trip really from basically Washington, D.C., okay? So how long does it take to fly from D.C. to L.A.? Like 5 hours, something like that?
Yeah,
5 hours?
with the change.
Yeah. So we go to L.A., okay? From L.A. we grab another plane, and we're going to cross the Pacific, go to the South Pacific, and we're going to fly to New Zealand. All right. Now, when we fly here, this flight actually takes between 13 and 14 hours.
Yeah.
All right. We land in Auckland, okay, and we'll take one more flight, and then we'll go to the South Island of New Zealand, which is Christchurch. The main city is Christchurch. And from here, we'll take a military flight, and that will go straight south, and we'll go to Antarctica from there.
Wow.
All right. And we go to McMurdo Station. McMurdo Station is actually on the very southern tip of a peninsula, and you can see it here, all right? And it's on a volcanic island. And this is about 60 miles actually off the coast of Antarctica, but it's really connected because there's a big permanent glacier that connects us. Okay. So we can drive right across to the continent, okay? Now, I'm going to back up one step. We're going to back up to Christchurch just for a minute, okay? Now, the trip that we just took, really, in reality, takes about 3 days. Because you have to get from where you are, you have to get to LA, you have to get to New Zealand. Then when you're in New Zealand, when we're in Christchurch, we're at this base right here. And we share this base with the New Zealand government. And we share all of our resources and power, but also logistical resources. And we have a shared base here. And what we do here is we prepare all of our cold weather clothing and any kind of material. And we prepare it, we put it on cargo planes and ready to go to Antarctica. And this process sometimes takes a while. But our main job here right now is to try on all of our clothes before we actually even leave, okay? They ask us to fill out a form with all of our clothes sizes and our gloves and our hats and our boots. I have my boots right here actually.
More.
Yeah, you can see them right here. These boots and
weigh a ton.
You can see.
Ooh.
Okay.
Look like
The boots. In Spain, I have the jackets where we have a whole warehouse of jackets and different kinds of cold weather clothing. And the people here, their job is basically to take the information that we have, that we filled out, and they prepare us each 2 of these bags. We have 2 of everything, 2 jackets, we double up on everything. And they put it according to our sizes that we need, all right? And then we take a few minutes and we'll try them on. This is a quick video that I rescued from my mom's house a few years ago from the VHS, and I passed it to DVD. But you can see here, we're just in the dressing room, and we've got all of our stuff out, and we're trying everything on. And you would say, well, yeah, that's important, but why is it so critical? Because the flight to Antarctica isn't by military aircraft. So you can imagine if you get down to Antarctica and your zipper doesn't work, what do you do? Right? Pretty crazy. Really hard and really expensive too, because it has to get on a plane to get down to Antarctica. So we're worried about the resources that we're using. Okay? So this is what we're doing. And we try on our clothes and make sure everything fits make sure everything works. If it doesn't, we turn it back in, and they maintain the clothes there. They patch things up or replace the zippers or whatever, okay? So we do that,
How
and then
many-
we pack it back in the bags, and then that gets put on the plane along with us. So here we are. These are two really good friends of mine, actually. And we're on a military aircraft. For those of you who've been in the military, this particular one is a C-130.
I've sat
okay?
on them.
It's a propeller aircraft. And those of you who have been, that have actually had the pleasure of being on these aircraft, they're really loud.
Yeah.
Really loud. So you can see, we're all wearing ear protection.
Right.
Yeah? And you can't hear. If you've ever been on one, you can scream at somebody and they're right next to you and you barely hear them. It's
I've been on one.
incredibly loud. And of course, we're packed in like sardines. And if you haven't been on these aircraft, you don't sit, you can see the seats, they're just kind of like a net, really, that you just sit in. And they're very configurable. You can take them and make more seats or less seats so that you can have big pallets of cargo, more or less people, okay? So we can adjust the load for each particular flight, okay? And this is another flight that I took. This is a C-141. This is a jet. So it's a much longer plane, but some interesting things about the photo. I'm so sorry. Some interesting things about the photo, I'll just change sides. As you can see in the rails that are going up, the support rails, the oxygen mask,
Yeah.
okay? They would normally come down from the ceiling. Well, we have to actually physically take them out if we have an emergency, okay? And a really interesting fact is the bathroom is way, way, way back there on the front of the plane. And so, of course, if you're here, you gotta bother all these people just to go to the bathroom, you know? And it's nothing but a curtain
Yeah, I
hanging on a
know.
rod in a corner.
I know, it is,
And
that's
you
right.
have literally no privacy, you know? Feel bad for the people sitting next to the bathroom, but that's the way it is. That's how we travel there. So 8 hours of flying like this, and we get down to McMurdo Station.
How many are in your room?
In each flight, well, it really depends. It could be 50 people, or it could be 250 people. And actually, these days, they've got bigger planes. They have the Galaxy C5A.
Yeah.
They've got the C-17, and actually they got a newer version of the C-17. The C-17 is actually an aircraft that has 2 decks. They got a cargo deck and a passenger deck. And I'm not sure how many people will fit on that, to be quite honest. So it really varies depending on the time of the year and the needs of the station.
Okay.
Okay? So what have we done, really? What have we done? If you look, this is South America, okay? And of course, North America is on the side. We're looking at the southern hemisphere. We've taken a plane. We've traveled all the way around here to New Zealand, to the top of New Zealand. We've flown to the top of New Zealand, right here. And then we've flown to the southern part of New Zealand. And then we've taken a plane right here. We're going to take one more plane. But we have to wait approximately a week to 10 days for our bodies to get accustomed to the atmospheric conditions that are down there, because they're very different than what they are here. Even though we're at sea level, they change drastically all the time. So it takes a little bit of time to get used to it physically, okay? So after a week or so, week, 10 days, we take another plane. And that plane from the coast, McMurdo Station, to the South Pole is 3.5, 4 hours. I mean, it is kind of like flying halfway across the United States. I mean, that's crazy. So here we are. We're arriving at the South Pole. All right? This is the landing strip, and we call it a landing strip, but it's 2 miles long. Okay? But you can see the station off to the right-hand side. All right? And off to the left-hand side, just you can see this little group of buildings there, okay? That is a telescope, radio telescope, and off to the left, the farther left off the picture is an area what they call the quiet area. Nobody can go there because they've embedded in the glacier detectors for neutrinos. Neutrinos are non-charged particles from the Big Bang. And they're actually passing through us right now at millions of miles an hour. We never feel them. And they're very hard to detect. But it is a scientific way of proving the Big Bang or disproving the Big Bang, and also being able to detect how fast the universe is expanding or contracting, and which way it's going, okay? There's a lot of technical stuff that I don't know, but that's my understanding, okay? Anyway, so the main base is over here. The landing strip here is just snow. It's packed snow, okay? That was part of my job when I worked down there, was to help prepare the runway here, okay? And only C-130 aircraft can fly to Antarctica. No wheeled aircraft. The C-130s are specially equipped with these big, huge 2,000-pound skis, and they have to fly on the outside with the skis out so they can land on the snow there, okay? So what we do is we pack the snow down so it's a certain density, and that way the plane can land safely. And I don't know if you've ever heard, but in the winter down there, there are no planes that can land at the South Pole because it's just too cold. And you think, well, why would it be too cold? I mean, cold is cold. I mean, 60, 80, 100 below, yeah, that's pretty cold. And it does get 100 below at the South Pole. But anything below 75 below zero, and what will happen is, if the planes, the rubber gaskets that actually, the hydraulic fluid from coming out, okay, they actually freeze and crack. And so what happened, you can imagine hydraulics holding the plane up with the skis, and the hydraulic oil just blasting out over the place. So the plane ends up losing its ability to hold itself up and sits belly down on the ground, so it's stuck. So they don't allow you to fly or land the plane there below, I think it's below 75, okay? So anyway, so here we are at the South Pole. And this is actually the geographic South Pole. One thing I like to point out, you can see there's a stick right here, and you can see another one in the background.
Yeah.
Well, this one is the actual South Pole. All right. So if I were to put my hand on that pole there and walk around, what am I doing? Walking around the world. 30 seconds and nothing, you're walking around the world.
Neat.
Yeah, it's pretty cool. I got a video I'll show you in a second.
That's cute.
But you see the other one that's just about, what, 10 yards away or so? And you would think, well, why are there two? Can anybody guess why there would be another one?
One's magnetic.
I'm sorry?
Magnetic. South Pole.
You know, that's a really good guess, but actually, the magnetic South Pole, the same as the magnetic North Pole, is nowhere close to the actual physical geographical one, okay? So, no, I hate to say no. Anybody else have a?
Summer and winter.
No, because it doesn't change. Geographically, it doesn't change. Geographically, it doesn't change. There's a little, okay, think about it. Right now, we're on a glacier. We're about, I'm used to thinking in meters now, so I'm thinking almost 3,000 meters. So that's around 10,000 feet, maybe, not quite 10,000 feet in altitude on a glacier, most of which is ice. I mean, then you get to the land way down, okay? What do glaciers do?
They melt.
They melt, but they also move.
Oh, yeah,
Right.
sure.
And so in this particular area, they move about 10 meters a year.
Really?
Okay, this big glacier is, even though you don't feel it, because 10 meters a year is really nothing. I mean, it's edging along. And of course, you're 10,000 feet up, so you don't really feel all that force of the glacier moving. But it does move. So what happens is, while we're here celebrating New Year's Eve, okay, with our families and going out and dancing and having dinner, we have a USGS team of 3 fellows every year that goes down there, and they have their special equipment, and they re-identify exactly where the South Pole is, and they remark it with a new pole. Okay? And they use the old pole as a reference, because before we had the cool GPSs, they used the shadow tip method. And I don't know if anybody knows the shadow tip method of finding north and south, but it's an old technique, an old really easy way to find north, east, and west. using the sun and a little bit of time.
Oh, yeah,
So they use the GPS, but then they confirm everything with the old analog way of doing it. So it's pretty cool. Anyway, so there's the story behind the South Pole. And you can see here,
It's a little windy.
here I am, waving to Mom. I made this video for you. And you can see these flags here,
Yeah.
okay? The base is behind, all right? And this is actually the ceremonial South Pole. So this is about 100 meters away from the other one. And it's just for pictures and ceremonies and things like that, okay? But you can see how windy it is.
Yeah.
Really super windy. An average wind is about 19 kilometers an hour. So, 15 miles an hour, so to speak, maybe.
That looks
Okay.
like more than 15.
And it's about 40 below right now without the wind chill.
Oh,
So you can see that my mustache is all iced up, all right? See if I can forward this a little bit.
oh yeah, I saw.
Okay, so I'm gonna walk around the world here in a second.
That is so neat.
Yeah, it was a privilege. It really was.
Just think of that. I love that.
Gotta wave to Mom.
Look,
Gotta wave.
that's so good. His mustache is broken.
And you can see here, 90 degrees south, geographic South Pole. Every year that they come down and mark the new one, they put a new plaque down there with the initials of the fellas right along in here, okay, that actually did that particular plaque. So each one is handmade, it's brass, and it's individual, unique. Okay? So let's go to the next one. And here's a quick video about the old station in Antarctica, in the South Pole.
An igloo.
Okay?
How neat.
We'll put it on pause just for a second. Now, this dome is just part of the base. And it's really about 4 stories tall. 4
Really?
or 5 stories tall. And inside of this, I'll show you in a second on the video, there are other critical buildings, okay, that need to be protected from the snow and the wind and the climate, okay? So what they've done is we built this dome here and we put the buildings inside to protect them. And we have the communications, we have the galley, we have a couple of living quarters and some offices inside, okay? Then the rest of the station is separated out in smaller buildings, or at least it was. When I was here, I actually stayed, I forget what you call it now, it's been so long since I've said it in English. But basically in one of the, the Gomer Pyle long barracks U-shaped
Yeah.
dome tents, okay, it's actually a tent, okay? And insulated, and it was warm inside, but it was still a tent. And to go to the bathroom, you had to go outside to the other building, 50 meters out, Yeah, so at night, what do? You have a little basic bottle, really.
Exactly.
And you have it colored one color, your water bottle colored another color. Oh yeah, you don't want to get those confused. So anyway, so this is a little bit about,
Is that ice?
yeah, this is snow.
Yeah.
It's a really good observation.
Looks like an igloo.
Yeah, but what happened is when we first built this, I didn't build the first section, I helped take this one apart. When they first built it, it was built actually on the ground level.
Uh-huh.
So the whole dome, you could see everything, right?
Right.
But because of the wind, constant wind, okay, any obstacle the wind encounters on the leeward side, it creates a turbulence, okay? And that turbulence, as the snow comes across with the wind, it builds up like a drift, any drift that you would have here.
Yeah, we
Same
have
thing.
big ones.
Okay, so it drifted over years and years and years and slowly got covered up, okay? And of course, the weight of the snow would just crush the dome. So the United States had to decide to make a change of plans because Antarctica is a protected reserve. So we cannot leave anything there. Everything that goes comes back. Everything. Human waste, construction, food waste, everything. So there is nothing that gets left behind. So what do we had to do? We had to take all this apart, all the buildings, everything apart. And I mean, this was a multi-year project, obviously. And at the same time, build a new station. Okay?
Wow.
And so that way there's no trash left behind and it's left just as pristine as we found it. Okay? And so that was a really good observation. Allow me to get into that. I'll just show you a little bit more about it on the inside.
Yeah, that is incredible. And that's all ice there.
This was what I used to operate down there to help maintain the runways. You can see some of the living quarters here.
Now, you don't just deconstruct those.
Excuse
You
me?
don't deconstruct those living
We
quarters.
had to deconstruct everything.
Well, when you showed us the base as you were coming in, there's already something there.
Yes, ma'am, we took everything apart. I'll show you why in a second.
Wow.
You can see inside the dome here,
Yeah.
we have the buildings, and we have basically a big hole at the top for all the vapor to escape.
Okay.
Because why? You can see how it freezes on the top,
Yeah.
okay? If it freezes too much, the weight of the ice would collapse the dome.
Collapse the dome. Okay.
So we had to, have that open. And here are some of the buildings, and it's not cold inside, it's not warm inside the dome, it's warm inside the buildings, but the dome is just a protective shield, basically,
Right.
okay?
That's incredible.
How do they heat the place, Richard?
I'm sorry?
How do they heat the
Right
buildings?
Inside of the buildings.
Yeah.
We use basically airplane fuel,
Okay.
okay? And Mom, that's a really good question too, because what would anybody imagine be the most precious resource at the South Pole?
Fuel.
You would think fuel, and that is an important question, really important. But water.
Water.
Water. Somebody said water, and you're absolutely right. Why? Because we're at 10,000 feet. We're in the desert. Antarctica is really a desert. We're on top of a glacier, tons of water around us, but the air is so dry, it just sucks your body dry. I had to drink, the leader, okay? That was in McMurdo. That's on the coast. Here I had to drink a lot more water. You are constantly drinking water. You get sick of drinking water. You're drinking water and you're peeing the whole time. Literally. And if you're not, you're gonna get dehydrated, you'll lose your consciousness, and you're out in the middle of all this, and you could easily die. So it's a constant battle to stay hydrated. So,
Isn't that interesting?
to go back to the water thing, okay? Water is the most precious, but how do we get the water? We have to melt the snow.
Yeah.
How do we melt the snow? With fuel.
Right.
How do we get the fuel? It has to come from the United States. How does it come? It comes on a tanker once a year. We take a tanker, we go all the way down from the US, go to New Zealand, stop in New Zealand, then it comes down in February to McMurdo Station. We unload the fuel there, then we actually have to fly the fuel to the South Pole. And there's big fuel storage tanks, that we store the fuel in for the year. So during the Antarctic summer, which is October through February, we do constant flights, 4 or 5 flights a day, as many times, if the weather permitting. And we fly fuel and materials down to the South Pole for the next year. So we do everything in just preparing for the next step, okay? So it's so costly to bring anything down there. And that's why I say water is so valuable. It's so valuable that we're only allowed to take 2 showers a week. and they can only be 2 minutes at a time.
Wow.
So what you do, you get in the shower, they've got like a key, you know, where you can, a little turn thing, you just turn the water on and off, you get it the temperature you want, turn it off. So you're already wet. You put the soap on, and you turn it back on, you rinse off, and that's it. That's it, that's all you get.
Since it's cold water, you're good.
Yeah. So anyway, that's a little bit about what it's like to live down there. There is no telephone. If I were to want to call my mom, it would have to be via radio. So I would use a phone, it would be uplinked to a satellite. That satellite would go to the radio transmission here in the United States and then call to her landline. But if you've ever talked on a walkie-talkie, right, it's the same interaction. It's like, hello, over, and you're waiting, right? So it's that interaction. I haven't been in Antarctica since 2002, so I don't know how they've updated the system. I'm sure it's not exactly the same, but that's what it was when I was there, okay? Now, when we deconstructed and constructed the new base, which this is it, we took all those buildings and we put it into one, okay? So it's safer because you don't have to go from one building to another, okay? It's much more efficient because we don't have to heat however many buildings. We heat one and it's a better insulated building, it's newer. All the science, the laboratory, the living quarters, the cooking, everything is right here.
And I see it's all elevated.
And it is all elevated. Another great observation. Why would it be elevated? Anybody care to guess?
Well, yeah.
The snow, yes ma'am. Yes ma'am. This way the snow can go underneath the building when it blows and the building can stay completely elevated the whole time.
Like the beach.
And it's even, these stilts that we have here are, we can actually lift the building up and put another ring on top. So as they sink down, we just lift the building up and keep it maintained. So we never have to build another multi-million space station at the South Pole. Is really what this is.
Now, that's not demolished when you leave, is it?
No, ma'am. No.
Okay.
This is well, technically, we're not allowed to have anything permanent.
Yeah.
So technically, this is designed to be able to take apart and bring back to the U.S. If we ever needed to.
Okay.
But the idea is to maintain it permanently so that we never have to go through that cost
Yeah.
of building another station.
I was
They're
gonna say.
like modular buildings.
Yeah, they are. They really are. Yeah.
And what is that round thing for?
This is a stairwell.
Oh,
Really?
Mhm.
Interesting.
Okay. So just a couple of little information points about the climate down there. And these are kind of roundabout numbers, okay? Minus 81 Celsius, which is, you know, way below 100 Fahrenheit, okay? Actually, at the South Pole in the wintertime, they have I've never spent the winter at the South Pole, but I have spent 3 winters at McMurdo Station, which is along the coast. And we'll go there in just a second. There's a club called the 300 Club. And when it gets to be a minus 100, excuse me, I'm so sorry. When it gets to be minus 100 outside, we'll turn the sauna up to 200. And we'll get in the sauna for as long as you can stand it. And then, and we'll share something intimate with nothing but your tennis shoes. You run outside, do a trip around the South Pole, and then run back inside. And then you remember the 300 Club. Because you just changed 300 degrees, right?
yeah, right.
So, as I said before, the precipitation is minimal. We have lots of storms, and I'll show you a video of a storm later on, and you can see it's really, you know, obviously, it doesn't snow like this so often. Along the coast, yes, but in the interior, no, it doesn't ever snow. It just blows whatever is on the top, okay? And it's so dry that I will never forget, actually, the first time I ever landed in Antarctica. Because when they opened the doors to the C-130, I could feel my sinuses and my skin just go, and it just sucked it away from me immediately.
Wow.
Yeah, it's crazy how dry it is. So, you know, and of course, windy, you saw the wind, all right? And in the South Pole specifically, there's only one sunrise and one sunset a year. And you say, wow, one? Yeah, one. And I'll tell you how that happens. If you can imagine, well, let me see. I'll hold that story for one more slide, because I got a better slide to show you. This just kind of shows you a cross section of the density of the ice versus the continent, the actual landmass. And it's just kind of a neat graphic to see where all we're at. South Pole is up there, and then we have McMurdo Station right here. Now, this area right here is what they call a permanent ice shelf. It's a big glacier that's actually floating on the ocean, okay? You've heard about the big glacier, or the big icebergs that are falling off. This is the other one. This is called the Ron ice shelf over here, okay? And that's below America. And whenever you hear anything on the news about those big icebergs coming off, that's the area they're coming off. They do come off in our area as well, but we're a little farther south, so we're affected a little bit later, okay? So we're going to go from the South Pole, and now we're going to go to this little dot right here, okay? And that is McMurdo Station. And as you saw on the little Google Earth that we had there, we're right here, okay? There's two little dots right here. And you can see there's two right here. This one is actually an active volcano. This is Volcanic Island. It is the world's southernmost active volcano. And I wished I had some rocks. I have them, but they're not here. They're in Spain with me. But I have rocks from this volcano. It's amazing.
Is it still active?
It is still active, and it is actually one of the two volcanoes in the world that creates crystals. In the lava lake at the top of the volcano, for the I don't know what the story is, but I think it's the chemical makeup of the lava and that comes up, that it creates these crystals in the feldspar class. If you know anything about that, I don't know too much about geology, but they told me that's what it's made of. And so what will happen is it's not a really, not like Hawaii where you'll see the lava flying out of the volcano, but you will see smoke coming out every day. And so it kind of gurgles, for a better lack of a word, right? And so you see these, the scientists, when they go up there, inside the crater, as the volcano doesn't have enough really energy to throw things so far out, it just kind of burps small rocks out. And they contain all these little crystals. And then over time, the elements combine and they erode the pumice away, and you're left with all these little beautiful black translucent crystals, kind of like a gravel around the crater. And the scientists are so nice because they go up there and they study this, but then they grab a bunch of crystals and they give them to us as kind of a thanks, for supporting their work, okay? Anyway, so we're going to go down and we're going to pop into McMurdo. This was the view, believe it or not, from my room. I was so fortunate because I had spent so much time down there that I had ocean views, okay? So this sign was just right outside of my window. And I took this picture in 1999, I think it was, February 1998, excuse me, 1998. And you can see the ocean here, and it's fairly ice-free. Normally, that's completely solid, full of ice. And we were out there working on it. We land planes out there and everything. And then in the back, of course, you can see what they call the Trans-Antarctic Mountains. And these mountains are really tall. They're like the Alaskan range, if anybody knows those mountains. They can get up to 14,000 feet. And there's a lot of science that goes on over there. So we take helicopters and scientists every day over these mountains, okay? And here's a little bit kind of a zoom out shot of part of the base, okay? And you can see this big white building here in the middle, all right? All right?
Now that's all permanent.
Excuse me?
That's all permanent.
No. It looks permanent, yes. But to be honest with you, if you Google McMurdo Station, you will see the future project. All this is going to end up the same way as we did with the South Pole. They're going to take all this away, and we're building a central building that contains everything. Okay, and you can't really see, it's hard to see, but their buildings are basically on pilings, concrete pilings.
Yeah.
And these pilings are just set on the ground. So they're foundations that are not actually in the ground, they're just supporting the building. So when we take everything apart, it's like a jigsaw puzzle, we just undo everything, package it up, send it back to the United States, and, take care of the ground, we kind of try to put it back the way it was before.
Wow.
So it's all temporary, it looks permanent, but it's really all temporary. And by law, it has to be that way. Yeah. So these big brown buildings in the back, that sign that you just saw is that one right there.
Yeah.
And my room is right here.
So those are barracks.
Okay, yeah. And there are a lot more over here to the, kind of off the picture.
Yeah.
But we have a chapel.
How long do you have the stations right there before you take them down?
McMurdo Station was started, I believe in 1957, somewhere along in there, and it was started by the Navy, and it was done with the old Gomer Pyle huts, okay? And the Seabees were the ones that were down there, and they maintained the base for us, and then eventually it got turned over to the National Science Foundation. And so there have been building upgrades. Sometimes a building will get torn down, they'll put a new one there. Believe it or not, there was actually a nuclear plant there at one point to provide fuel for the generators, but they've since decommissioned that, taken it down. So there's been modifications over the years, but the project that is in the works right now is on the scale of what we've done at South Pole to make it, more efficient. Okay. So like I said, we have a chapel. We actually have 3 bars.
I'm sure.
It's important. We have a department there that takes care of, and for the fellows that have been in the service, we have a morale department. What do they call it?
MWR.
MWR, yes, sir. MWR, it was in my brain. And so they take care of planning all the parties, all the activities. We have like indoor soccer league, basketball leagues. We have races. They rent bikes, they rent skis, they rent whatever you want. And so you would think, wow, what do you do in your off time? Well, it's all taken care of. You can do whatever you want. Not only that, a lot of people here like to donate their time as volunteers to the community. I personally, for example, once or twice a week, I would give dance classes. So, I have friends of mine that would teach languages. Other friends of mine that have knitting clubs. I mean, card clubs. We play cribbage. I mean, you name it. And people just get together, So you add whatever flavor you can to it, and it makes it a really nice community. Okay, so
There goes the sub.
this is a photo that is my personal favorite in the whole presentation. And I'll tell you
I
why.
don't blame you.
You can see the mountain, you can see Erebus, that's the name of the volcano. You can see the smoke coming off. And the little dark patch at the bottom there, that's that peninsula of land that our base is on, okay? So our base is just right there. And I'm about probably 25, 30 miles away from the base. And my job, I had a very, I wouldn't say privileged position, but I would say I was very lucky, very fortunate to have the position I had. Because in Antarctica, you're not allowed to go out of the base by yourself. You always have to have somebody else with you. Yeah, it's like when you're hiking in the mountains, you have to make the safe thing to do, right, is to make a plan, tell the rangers, tell your friends, okay, I'm going here, I'm coming back this way. If I'm not back by this time, come looking for me, okay? Same thing there, but every time you walk out, you have to go with somebody, you have to take a radio, you have to inform somebody, it's a really big deal, okay? So you don't have any alone time. It's very difficult. You share your room with somebody else. You share the bathroom with a bunch of other folks. So it's real hard to have that alone time. And I don't know about you, but I like my alone time. I went there for my alone time, and that was the biggest shock of my experience down there. I'm thinking, I'm going to go to Antarctica. I'm going to have all this time, all this space just to myself. No, it's just the opposite. You're just in a fishbowl, man. It's incredible. So here I am. I'm out all by myself doing my job. And this is August 22nd, 1999. okay? And the sun had just come up. I had just spent 4 months in total darkness, okay? After my very first winter in Antarctica, okay? And at this moment in my life, it still makes me emotional to think about it, because they tell you when the sun's coming up. They tell you exactly the moment that it's going to come up. And I was looking for it. And that's really all you see the first day, okay? It pops up and it's up for 10 minutes and it comes back down. And so I shut the machine that you saw in the earlier video. I just turned it off. And this particular, you can see the flag right here. That kind of marks the road that I'm on, okay? And there was no wind. So it's just silence. Your ears actually strain to hear something. And there's nothing there, nothing. And then you look up and you see the sun. And it's the first time you've seen any light, the sun, for 4 months. And I literally had, tears coming out of my eye with emotion of this particular moment. Because at that moment I realized, wow. And what had happened is, over the 4 months that I had spent in the winter there, you don't realize it until something like this happens, that you kind of slowly gotten slower mentally. You're kind of almost in a dream state, but you're awake. Your reactions are slower. You're more temperamental. You get in more arguments. Your emotions, you forget things. I mean, there's been studies your short-term memory just goes. You can't remember anything. I've had friends say, I called somebody thinking, and then say, you call a person, you say, hey, hello, what do you want? And you were the one that called. So it's difficult down there. And this moment was what actually kind of woke me up, so to speak. It's, wow, there is life, right? So for me, this was a very special moment.
Was that a twilight darkness or dark darkness?
Great question.
I was thinking part of it.
Yes, sir. You're absolutely right. In McMurdo, also at the South Pole, just before the sun sets and just before, in McMurdo especially, we do have the seasons, but they're much different in time as what we have here. In McMurdo, we have about 4 months of light, and 4.5 months of light, 4.5 months of dark. And then in between, in the spring and in the fall, we have about 5 weeks or so where there's some twilight. There's also some night and day. Okay. And right before the sun comes up, the sun is actually below the horizon. So you do get the twilight all day long. And you know it's coming, but you actually don't see it till it comes up, right? And what will happen is, the sun will come up here, and it'll come from the same spot the next day, and it'll come up a little higher. And it'll come up a little higher the following day and set. You add about 10 or 15 or 20 minutes a day of light, okay? And then eventually what will happen is the sun, the trajectory will get longer and longer, make bigger arcs in the sky, and eventually it'll actually come above the horizon and stay. And that's in October, beginning of October. And actually the sun will actually follow the horizon 360 degrees.
Really?
Yes, ma'am. Yeah.
It's incredible.
All day long. And that starts the summer. 24 hours of light. And as it's really low in the sky, as the summer progresses through December and January, what happens is those circles that the sun does around the horizon, they get smaller and smaller and also higher and higher in the sky.
How high does it go?
Well, I'll show you a picture in a second, but it's like you're looking up and the sun, if you were laying on your back, the sun does this.
Really?
Yeah. If you had all day to do that, right? But yeah, that's what it does. It never sets. And then the reverse happens in the fall, right? The circles get bigger and bigger and bigger and bigger, right? And then the sun sets, and then you have the twilight that just lasts, it's like a 24-hour sunset for days and days and days and days. Okay?
But instead of going this way, it goes this way.
Yes, ma'am.
That
Because
is,
we're so far north,
yeah,
right? That if we were looking south here,
yeah.
the sun comes up in the southeast, right?
Right.
Not in the east, in the southeast.
Southeast, right,
And it follows the southern sky to
Yeah.
the southwest.
right.
If we were on the equator, it would be different, right? It would come up in the east, come directly overhead and fall in the west, okay?
Yeah.
So here I am. This is my very first year there. It was 1994, August of 1994. I was out and I was working as part of the search and rescue team, okay? And you
Okay,
can see these green flags behind me here,
yeah.
okay? Part of my job down there as part of the search and rescue team was to, for better lack of a word, pathfind. On the ice, I'm on the sea ice. This is the frozen ocean right here. I've got about 3 meters of ice below me, okay? And I'm driving on. If you think about when the ocean freezes, it doesn't freeze in one solid piece of ice. It freezes in little bits, and then they join together. And it looks solid, but then they act
Okay,
of the earth, right?
yeah.
So what happens? We all know the movements, right? The tectonic plates, they move like this. They kind of bump each other, or one will subduct underneath another, or they'll actually just part, or they'll rub like this. All those movements that you see in the tectonic plates happen with these ice plates that happen, okay? So every time you see a crack in the ice, a joint where this movement has happened, we have to cross that to get to whatever science that they want to do. Well, part of my job was to find that path and define, is this a safe crack to cross or not? How big, how wide? Because what happens when a crack opens up, say we have 3 meters of ice and the crack opens up. Well, there's no ice in that crack, but it will freeze again, but it won't freeze 3 meters thick. It might freeze, this. So is that safe to travel with the vehicle? That was my job to find out how deep that was and how wide that was and if it's safe or not. So then if travel is safe, then I mark a trail with the green flag. This is where to go. If it's not, I put a black flag and you can't go here, okay?
How do you find out what method do you use?
I'm sorry? Go ahead.
About food, where do you get it from and how you cook it?
Well, we have what you guys have here, a cafeteria. We have a whole system where we have one cargo ship and one fuel ship a year that comes down.
It don't grow, you can't grow anything there though, can you?
No, ma'am. No. We have a greenhouse, but it's not to provide food like on a mass scale because in McMurdo, we're talking 1,000 people or so, okay? In South Pole, maybe 150. So you can't grow enough food in these conditions for that many people. So we bring it in from New Zealand, fresh food during the summer. In the winter, it's all frozen or dry. And then it's like what you have here. You have a cafeteria, you go eat at. They prepare your food for you.
Okay.
And you had a question?
Yes, how do you ascertain when you have to decide, what method do you use to decide whether it's safe, which are
It's a
safe?
really great question. How do I find out how deep the ice is? I drill. I use a hand drill.
Okay.
What we call an auger. And I just drill down, right? And I do what's called profiling. And if you think about it like kind of steps, but just reverse. They're going out, okay? So you'll have the 3 meters of ice, then it'll be a little bit shallower, a little bit, and a little bit, and then you'll get to the actual crack. So, and then we have tables that tell us, okay, you have to have this much ice for this particular vehicle to cross. And so then I can calculate, okay, with 1 foot crack, I can take of open ocean, for example, I can take a certain vehicle across and it's all right, or it's not, okay? So that's how I found out.
I want to ask you something.
Sure.
I want to know, why is it that you got
I didn't hear it.
I want to know, why is it that you cannot keep all this stuff in audit? Is it something, you got to bring it back to the United States, I understand. Why do we have to bring the feces and food and all that back to the United States? Is it something there that it affects something?
Yes, ma'am. It
Okay.
actually is the law, international law, in agreement with the Antarctic Treaty that was signed to protect Antarctica from exploration for commercial purposes, okay? And it is also an ecosystem that is very pristine. So as it is considered a nature reserve, basically, I mean, a very general term for what it is, but we have to respect what the international law says. International law says you cannot leave anything there, nothing. So we leave it as we found it. Because imagine if we just trashed it up, it wouldn't be worth anything to research.
Believe me, they would.
Right? It's just like Mars.
It's for research.
Absolutely, all for research. Yes, ma'am.
What organization has control of Antarctica? You spoke about international law.
Yes, ma'am.
Who actually controls Antarctica?
Well, the international treaty is what really governs Antarctica.
Yeah.
It's actually divided up into political zones, of which the United States has no claim, not one. Even though we're the ones that really provide most of the support to the science that goes down there, if the Antarctic Treaty were to ever be dissolved, it would be divided in these. Russia has a claim, New Zealand has a claim, I think France, Great Britain, but the United States, of that little pie, we have zero. But that's okay. I mean, we're there to do the science, right?
Are there any animals there?
I'll get to that in a minute.
What's the warmest it ever gets down there in the summer?
About 32. 32 degrees
Above or below?
below. I mean, excuse me, above. In the coast, on the coast. In the South Pole, doesn't even get to zero.
It never gets to zero.
Never gets to zero in the South Pole. And but imagine, I'll get to this side, but imagine you're out on the ice and it's 32 degrees and it's a sunny day and there's no wind. And the sun is just beating down on you.
It's
And it
hot.
also reflects off the snow. So really, you get this thermal heat from the sun that counteracts the cold, so you don't really feel the cold index is a lot. If it's a really nice day, you don't feel it so much. But of course, I mean, in the spring, which is the coldest time of the year, at least at the coast, it's minus 60 every day, and you're definitely. I mean, these guys, your feet are cold in these.
Ooh,
Yeah.
that's
So this gives you
beautiful.
an idea about what you're talking about, sir. The twilight. This is a 24-hour
That's beautiful.
view that we have sometimes, you know.
Gorgeous.
And this is a photo. We were talking about how the sun does its little circles in the sky.
Just to make you feel at home.
Here you go, Mom.
Oh, thank you.
Oh, yeah.
So this photo was actually taken at midnight in the summer,
Beautiful.
and you can see
That's a
we have
great
the
photo.
glaciers here.
Isn't it?
That's a great photo.
And I can't take credit for this. This is not my picture.
Beautiful.
But you see the ocean here?
Yeah.
That's the frozen ocean, and this is actually a glacier. And one of my friends had taken this picture because I had, again, as part of the search and rescue team, I volunteered my time to take people exploring the glaciers. So as this glacier comes out, actually, it floats out over the ocean when the ocean is actually, when the ice is melted. And what happens is the water carves out the underside of the glacier. It makes these kind of caves. So then when the ocean refreezes, you can crawl into these caves, and it's just a spectacular
Oh,
view.
wonderful.
So I used to take people there on little outings on Sundays. Okay, so he gave me this picture.
That's gorgeous.
Do you have to have permission to go there? When you go out there, do you have to have permission?
Absolutely, you gotta have permission. Yeah, you have to plan everything. Yeah. All right, so here's a video. This was taken by a friend of mine. He's a Kiwi. As I said, the American base and the Kiwi base, we're very close. We're about 3 kilometers away, 1.5 miles away from each other. So we work a lot together. And he took this video. He did this video. His specialty is time lapse, and you can actually find this video on YouTube. That's where I got it from. And you'll get an idea about how the sun moves across.
With the sunlight, take the time, that's not 12 o'clock. It's 12 o'clock midnight, right?
Midnight.
And I want you to see how relatively flat the trajectory of the sun is. There's a little bit of an ellipse, but not much.
Oh my goodness. That is so interesting.
Look how flat it goes, right?
Yeah. You have to remember it's the same sun we're looking at in an entirely different way.
Yes, ma'am.
Incredible.
Yes, ma'am.
Love it.
And the moon is reversed.
Oh,
It's
wow.
upside down.
Oh, wow. Now look how low it is there.
So anyway, that's the trajectory of the sun, okay? Now, I mentioned earlier we have lots of storms down there. Something I didn't mention is that there are a lot of storms. We have storms. We have a hurricane force storm at least once a month.
Wow.
At least once a month,
Now hurricane force, you mean 85 to 125?
or more,
Or more?
or more.
Wow.
Yes, ma'am. So strong, the winds are so strong that I have not experienced, I have not seen personally, but I have experienced winds that are very strong. And I got caught in a storm one time for 4. Do you guys remember that story about the doctor at the South Pole that had cancer in her breast?
Yes.
I was down there when that happened.
That lady.
Yes, ma'am. And we had to go out and prepare an emergency runway because, as I told you earlier, the plane couldn't land at the South Pole. So what they had to do was they had to parachute supplies into her. But in order for them to do that, they had to have a plan B, or an emergency runway. That emergency runway was at McMurdo Station. Okay? So we had to go out there with a team of 7 guys. Well, I was part of a team of 7 guys who went out there prepared the emergency runway. Just coincided with this huge week-long storm, literally a week long. And of course, in any storm, you're going to have lulls and really parts where it's a lot more forceful. And so in the times that it wasn't so forceful, we would go out and clear the runway. And in the times it was really bad, you go inside. And you always hear about it's so cold your pee freezes. I've never had that happen until this experience.
Really?
Only one time in my life.
They're talking about that doctor now, she treated herself with breast cancer.
Well, she diagnosed herself for
She
breast
diagnosed
cancer.
herself and they couldn't get a flight in.
Correct.
And they finally got into her.
Yes, sir.
And she got the medication, she started taking care of herself.
And then they flew her out when they could. Yes, sir.
And was
I
it?
remember reading that story.
Yeah, she wrote a book, made a lot of money.
Was it?
Pissed a lot of people off.
Was it? Was it?
Yeah.
Was it?
That's a whole other story.
Was it cancer?
But anyway, talk
Yes,
about
it was.
storms, okay?
Oh, good.
The gentleman that just made the prior video, this is his wife. Another good friend of mine. She lived right down the hall from me. And the video is taken from inside one of my, and this kind of gives you an idea about what a storm is like in Antarctica.
Really like what a condition 1.
All these are just dorm rooms right here, okay, that you share with one other person.
This is the entryway to our dorm. Normally this has carpet on the ground and the walls are just normally walls, but we're gonna open the door right now. It's a little bit like opening up the door to another world. Are you ready?
So what would the wind be? What would be the velocity?
Now,
What do you do, stay outside when, like, big storms are, when they have storms like that?
Yeah, just say.
It's not permitted to go outside, but of course, part of my job was to
Get that
go
right.
and find people that were outside that were lost.
And you want to go out in the weather?
Oh, yes, ma'am.
my God.
I've been out in this stuff driving, and I literally, the front of your pickup,
Yeah.
you can't see that.
Oh,
You can't see even the hood ornament on it. So you're driving and you have your GPS right here. That back then they didn't have GPS, is actually you had a handheld GPS, and you're looking at this, and that's the only way you know where you are. The only way, you don't even know if you're on the ground because you can't feel it. The wind is so strong, it's like it's like you're really in an airplane, but you have no sense of up, down, sideways, left, right, nothing. You can't see anything.
Did you find anybody?
Oh, yeah.
Oh, there were people out there.
Oh, yes, ma'am. We find them with we use what they call radio directional finder. It's a very simple way of finding people. Basically everybody has a radio and we talk back and forth and then you use the radio to figure out what direction they're in, okay? And then you just kind of zone in using your GPS to stay on a safe trail and we find them
And why are they there?
well, we're all out. A lot of people's jobs, like mine, was outside, and the storms can come in nothing. Even though it's not predicted, or you say, yeah, it's going to come, it can just change just like that.
Okay.
So
So
I mean, I've seen literally like a wall come from 70, 80 miles away, and you can see it, and it's on you in 10 minutes.
So they get caught.
Oh yeah. Oh, yeah.
I'm sure they would know about that. They
Yes,
would be
ma'am.
out there if they.
Was this at McMurdo or the South?
Oh, look at the.
This one was at McMurdo, okay? This one. And so you can see, this is, now the other photo that I showed you that was taken of the sun
Yeah.
at midnight, this is taken at noon in the winter,
Gorgeous.
okay? Again, I can't take credit for the photo, so it's different, a friend of mine, but I think it's a beautiful photo, so I use it. But it gives you a good idea. It's just dark. It's so dark there, sometimes you can't even see the ground. And here I am, I'm in the middle here, okay? And this is after about, I don't know, three and a half hours of, we were cross-country skiing. Yes, ma'am. And we were cross-country skiing, and it was so dark that I couldn't really see the ground because there was no moon this night. It was a new moon, and or this day. And we had, you're feeling your way with your skis and your poles, right? But it's so beautiful to be out there because you see all the stars. And honestly, right, we're in the northern hemisphere, right? We're looking at kind of in the spiral of our galaxy. We're on one of these outer arms, right? And the way the Earth is oriented in that, we're kind of in the northern hemisphere looking kind of out this way, being the plane of the disk of the solar system like this. So we're kind of looking out. So we see a lot of stars, yeah, but not so many as if we were looking towards the inside. And in the southern hemisphere, it's like that. You see not all, but you see a lot more. It's a lot more dense, full of stars. So the view is very different, much more densely packed, and it's just amazing. So of course we're out there enjoying that. And we also get to see cool things like auroras and things like that. But the interesting thing about this photo, while I put it up, is it looks like it's snowing. But it's not snowing. It wasn't snowing. It was perfectly clear evening, no wind, no nothing. So can anybody guess what that might be?
The sky.
Not the stars? No, ma'am. This is just right here next to us. And this is just right around us. Right? Particles of ice?
I don't remember what they were, but you were talking about the photos that like a volcano.
No, ma'am. Not volcanic dust. No, ma'am. These are ice crystals.
Yeah.
Okay? And they're just floating. It's like they're floating in the air. But they're so minute that you can't see them. And actually, this was, in our day, okay? You take the picture, you wait, you go to the store, you get it developed, right? I got back to New Zealand, I had this picture developed, and I'm like, wow! It was when we took it off of these, because I couldn't even see them that day. It's crazy. So yeah, it's so dry and so cold that even the littlest bit of moisture that's in the air just freezes right up. Okay?
Did y'all have sleds too?
We did. We used sleds.
So those are really in front of you.
Oh, you were sorry about that.
That was between the camera and you because
That was floating all around.
it was all the way down in front of
It
you.
would be like if we were to go outside right now,
Yeah.
when it was snowing and you can actually see it. It's the same thing, but you couldn't see it.
Okay.
Okay?
You ever see the moon?
Yeah.
Oh yeah,
Well, he
absolutely.
just showed you the moon.
So here's another picture. I just took this one off the internet, taken by another person. I have no clue who it is. because I'm not such a good photographer that I can take pictures of the auroras, but I've seen them, and I've seen them like this.
That's cool.
And it's a really good shot. This is one of the vehicles that we use, actually, and it's a track vehicle to allow us to disperse the weight of a machine across a wide area
Yeah.
to be able to travel across a zone that has lots of cracks or crevices in it, okay?
It's wide.
How do those colors come about? Is it like a prism?
No, ma'am. Actually, what happens, and this is a great photo to explain that question. Okay, the sun emits particles, right? Electrons, photons, negative particles, I forget what they're called.
Neutron.
Is it neutrons? Okay. Electrons, yeah. Okay, so there's positive and negative particles that come out of the sun. That creates what's called the solar wind, okay? Travels about 1,000,000 miles an hour, all right? In our magnetosphere, if you can imagine the Earth, right? We have a magnetosphere outside of our atmosphere, okay? That emanates from the two poles, and it is layered. It's like an onion, okay? If you can imagine an onion, and these layers are connected between the North and the South Pole, all right? What happens is as the solar wind comes in contact with the magnetosphere of the Earth, it's like a bow wave of a ship. So it comes in contact, the magnetosphere, and the particles actually follow a layer of magnetosphere into our atmosphere, and a particle will strike a molecule of gas, whether it's nitrogen, helium, oxygen, whatever, ozone, okay? And depending on that particular gas that it hits, that little molecule of gas, it emits a little shock of light, a little spark of light. So depending on the gas, each one has a little spectrum of light that it emits. So you can see here, you can actually see them, if you can imagine them coming in like this, right?
Yeah.
And that's what creates this effect, what we call curtains, right along in here, okay? So they're coming in, they're hitting this particle of gas, okay? And then they shoot back off using the same layer of the magnetosphere, and they go to the North Pole. And they go back and forth, boom, 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 like a ping pong, until they just run out of energy, and then that's it. But that's what creates these things. And if you can see them from the space station, they're lower than the space station, but they're higher than any layer of our atmosphere. Does that explain it?
Yeah. Very well.
So let's get into just the whole reason why we're there. Science. We study everything in the ocean we possibly can. Everything. The biology, the ocean floor, the currents, everything. We study human adaptation. I've been part of a study where they took over the winter like samples of fat tissue to see the chemical makeup of your body as it changes through the winter or the darkness. They do psychological tests. They do all kinds of things. How we adapt, how the animals adapt to the cold. Okay?
Oh, look.
Yeah, this one always gets that reaction. Oh. Anybody know what kind of penguin this is? Emperor, actually.
Emperor.
Does anybody know how tall an emperor penguin is?
It looks like they're very tall.
They're actually about 1 meter tall. 3 feet tall, a little over 3 feet. Tall, really tall guys.
Yeah.
And they're so personable, I have to tell you. Now, the Antarctic Treaty, we were talking about that a little bit earlier, okay? It governs everything that we do down there. We are not allowed as private citizens to bother the animals, okay? They call it molesting the animals, all right? That's the technical word they use, all right? And what do they do? How do you define that? They define it as if I were to move so close to an animal that they react in some way. They back up, whatever they do. That is a $10,000 fine.
Oh my goodness, scared of the animals.
No, but that, you're not allowed to bother them. Now, on the other hand, these guys are so curious that if you get down on your knees and you're like this, and you put yourself at their height, they'll come up to you. They'll come up to you and they'll peck on your clothes with their beaks. They'll peck on you, and they'll peck on your camera, and they'll peck on your tripod, on your clothes. And why do they do that? Because they're curious.
And that's the way they fight.
Yeah, and their beak is like our hands, right? What is this? What's this made of, right? Well, They touch it, and that's how they do it. Now, that's okay. If they come to you, that's okay. But you can't go to them. You have to let them come to you.
Oh, that's
Right?
interesting.
So that's the story. Now, this picture was taken, these group of pictures I'm about to show you are taken by the scientists that run what we call the penguin ranch. Okay? And the penguin ranch is what they do is they grab these penguins, these emperor penguins, okay? And they put them inside, inside like a big, they put like a big fence in a big area, probably about 60 feet wide or something like that, okay? And the reason I have these pictures is because I was working with these scientists on this particular project. We're out on the sea ice. This is the frozen ocean. And I drilled this hole right here, okay, with a big machine. I took a big machine that's like a big drill, you know, about 1.5 meters wide, and drilled it down into the ice, okay? And we put this hole, the scientists selected, and I helped them select the hole where the sites for the hole, because it's so far away from the next crack in the ice, the next hole where the penguins can get out, okay? That they actually, if they go diving to go find their food and they run out of air, they have to come back to this hole. So they're free, but they're kind of controlled, right? And if you can imagine, it's hard to, imagine we're in the, pretend we're in the ocean right now. Let's go to this next photo here. I'll explain one more thing. This is what they call an observation tube, okay? Now, see the white ring? That's where the surface. And I'm actually in a small chamber at the very bottom, all my jacket and my boots and everything on. And it's like a plexiglass, really thick plexiglass. And it's 360-degree view, but it only fits one person. Okay, so I climb down the ladder, and I'm here, and I'm actually below the ice, okay? And I'm watching the penguins. Because they'll dive in the hole and go swimming and go fishing, right? So the scientists use this to observe the penguins. And of course, since I helped put it in, I can be there and check it out. Okay? Yeah.
Interesting.
And of course, in our area,
Baby.
we have another kind of penguin. It's called a Adelie penguin. And this is more along the size of what you were thinking. It's about this big, okay? But they're a very different looking guy, right? They've got the little red beak and it's really short. But look at the feet, right? They got really big claws.
Yeah.
If you look at an emperor penguin's feet, they're a little different. They're more webbed, okay? These guys, they're webbed as well, but they got claws. And why is that? Because when they get out of the water, they like the rocky areas. So a lot of times they'll actually hop onto a cliff and just climb up a cliff. It's amazing what these guys can do. And they're really animated as well. They're super curious guys. You can see what we call a rookery here, okay, a penguin rookery. And this is where they're gathering to hatch their eggs for the summer, all right? And it's an incredible place to be because the picture doesn't do it justice, but it smells horrible. Horrible. And it's loud. I mean, you hear all these people, and it's the whole time, millions of them. I mean, just, and they're crapping everywhere, they're peeing everywhere. And so you oh no, what happened?
What happened to the dead ones?
They would have shipped back to the United States.
That was in Spain.
No, their stuff stays. Animal stuff stays.
Oh, the animals still, okay.
Oh, no.
For some reason, my presentation stopped. I don't know why. We'll just start it all over. Don't worry about it. Never had that happen before. That's the first time.
There you go.
Sure, I'm glad I didn't know all this when he was down there.
Oh, I bet you
Okay.
are.
Back to the penguins. So it just smells. There's lots of basically sewage on the ground, right? And the cool thing about these guys, you can see barely for those in the back, but there's an egg right there.
Yeah.
And you can see the little nest right there. They're made out of little pebbles. And the male is the guy that is the penguin that actually builds the nest. And the bigger the nest, the better chance of getting a mate, right? Oh, yeah. Believe it or not, that's the way it goes. Size does matter, right?
The bigger the house.
But the cool thing is, and you can't really see it right here, but there's another penguin right there. And there's another little nest right there. And they will steal rocks from one nest to another. And they fight over them. I mean, they get bad. It's really, they're territorial and they just love their rocks. So yeah, but this guy's hatching a penguin egg right now. And we have seals.
Oh, yeah.
Okay.
How cute.
Now this guy was just born. He's just a few days old. And he's got a sad story I have to share with you because
No.
if you can see in the back, there's some orange buildings.
Yeah.
Okay, that's one of our airports. Okay, he had gotten lost.
Oh.
The mother had basically abandoned him because once in a while, you know how we all have an internal compass, and these animals especially. And his was messed up in some way or another, and he went in the wrong direction, got away from the ice edge, and just died of dehydration. And the scientists in this case cannot touch him, because then they're getting involved with the natural selection of the ecosystem, and that's something they're not allowed to do.
Okay.
They were to be not respecting natural selection. So he ended up not too far after this picture.
Oh.
Here's another picture of another seal. This guy has a couple of months on him, 3 months. So he's much fatter, bigger, you know. So he's laying there happy. And this is a video I took.
Oh. Look at that nostril.
You can see me reflected in his eyeball there.
Yeah.
And I'm about, I don't know, maybe from me to you away. Not very far. He's not afraid of us. And what they'll do is they'll look for a crack in the ice, and they'll use their front teeth and they'll make a hole so they can come up and do exactly what this guy's doing right here. Terrible breath, smells like rotten fish. But just look at his nose.
I will wash them now.
Just huge, right?
Yeah.
And the colors around his mouth.
Yeah.
For me, it's one of my National Geographic moments, right?
Right.
Well, as he didn't react, and we were respecting our distance, it was okay for us to be there. We were probably about, I don't know, 100 miles away from the base at this point. We were doing this right here. Okay, so, and we had just, because when you're on the sea ice, okay, and if there's a crack, or if there's one of these what we call seal holes, just like when we're in the wintertime here, when we're breathing, you can see your breath. When they're breathing, you can see their breath. And if you can imagine this guy breathing up, it's like little volcanoes, so there's little steam spouts, right? So you can see it from a little ways away, from probably me away, or maybe us to the trash can away. So you can see, okay, there's a crack and there's a little fume coming out, so you can get closer to it. But it's also a warning sign, because it could be a dangerous area, right? Because there's a crack and the ice could move, whatever. So does that answer your question?
Yes, and then I have another quick one.
Okay.
Do you feed these, or do they have to get their own food?
No. Even the scientists are not, no. It is strictly forbidden to interact with them on that level. The scientists, when they study them, they do their scientific stuff, but they do not care for them in any way, if that makes sense. They eat fish and krill and different small things like that, crustaceans.
Are there birds too down there?
There are. This is like a Antarctic seagull.
Looks like a seagull.
They're called skuas, S-K-U-A, and they're very aggressive guys. If you were to walk outside with a plate of food, they would swoop down and try to take it. I've had it happen.
Yeah,
Yes, ma'am.
they're hungry, yeah.
They're pretty aggressive. They eat the penguins,
They do.
the chicks, not the big ones.
Yeah,
But they'll if they could get a big one, they would.
yeah.
Oh yeah. Now this is the other part of the penguin ranch. Okay. Now, the reason I bring this one up is because, you know, McMurdo, we function as kind of a hub, a scientific hub, so a logistical hub as well. the scientists from not only the United States, but New Zealand, Australia, Russia, France, Great Britain, Italy, those main countries come through our base and use it as a logistical hub to go out to their particular, because a normal camp is not 1,000 people. Normal camp's like 25, okay? So ours is big, it's huge compared to the other ones. But then from our base, even our scientists, not all of them stay or work directly out of McMurdo. They go and they establish a smaller camp, 10 people maybe, or 5 maybe, okay? And this is a kind of a big camp. We have a laboratory here that's ran with electricity with solar energy, but then it's heated with fuel from jet planes, okay?
Yeah.
We have one of those furnaces that we just light it up and there we go. In the middle we have like the kitchen shack where they'll do the cooking, and then the others where they bunk. You can see the window is whited out. That's so it can get dark inside so you can sleep, because there's just no way you can sleep with all the sun. Okay? And this just shows another kind of camp. This is just a smaller camp we're getting around on the snow machines, and this is a Scott tent designed by Robert Falcon Scott, but just updated with aluminum poles and more modern, but it's the same basic design that he used when he went down to the South Pole.
Well, that's so tall, but that looks more familiar.
And this is a mountain tent that we use for just a few days, and you can see Mount Erebus in the background, and we're on the sea ice here. And then we study astrophysics, okay? We study the cosmology, the origins of the universe. We study all the different atmospheric layers that we have. We study the ozone. We actually launch what they call long duration balloon flights, okay? And these balloons are just incredibly big. I mean, it doesn't look that big. You can see the reference of the people down here, but this is only part of the balloon. The rest of the balloon is laying on the ground. We're still inflating it.
Oh.
But there's actually a package of instruments that's taller than the ceiling, and gosh, from me to the door here, big, square, it's huge. And what they do is we launch this balloon, and because of the wind currents they just basically just go in circles around Antarctica, it does circles, it goes around, it gets up to about 100,000 feet.
Wow.
And of course, we all know that as you get higher in the air, I think you were talking earlier about the pressure in the plane, how it gets less and less as you get higher.
Yeah.
Well, as that happens, the balloon gets bigger, right? It's filled with helium. It's made of a mylar, so it's only just millimeters thick, super fragile. But it gets so big that you could fit the Panthers stadium inside this. It's huge, absolutely enormous. And then when it finishes, when the scientists determine, okay, they've gotten enough data, we use there's a small explosive charge that cuts the balloon off, and then there's a parachute that deploys. It falls down, and we go get the package for the scientists. Okay?
Wow.
So that's how they figure out things like this. How big is the ozone layer? How thick is it? Where is it? All the different cool stuff about that, okay? Now this was taken in 2000. It's a NASA photograph in 2000. Since then, there have been studies that saying the ozone layer is actually recovering. So now what happens is this is the ozone layer, the big hole, and in the spring it actually opens up. Because of the centrifugal force of the Earth, it actually spins it off, because the layer itself is not so thick anymore that when the atmospheric conditions are spring, the centrifugal force spins it from Antarctica. So that's how you end up with ozone hole.
Okay.
But in the summer, when the winds change, the atmospheric conditions change, it actually, the centrifugal force doesn't have as much, doesn't act upon it so much, so it is able to close up a little bit more. It's still thin, but it is recovering, which is good news. And these are just some sunset photos that I have from the fall. This is late February. And then we also study geology. And how do we study geology? This is Antarctica too. Imagine. There are places in Antarctica that there is no snow, no glaciers, nothing. Why is that? Because Well, in a way it does. But think about, like, okay, we have the Earth, and in a sense we have the South Pole at the top here, okay? And it's kind of like it's at 10,000 feet. And then you have, down here you have the ocean. And in between you have these mountains, okay? And as gravity acts upon the glaciers, they fall off, right? Due to gravity and movement and global warming. And they come through these mountains and they carve valleys like they would anywhere else in the world. But as Antarctica is a desert, there's nothing to replenish those glaciers. And that snowfall to make it, because glaciers take time. It takes time, snow, and pressure to form ice. And there's nothing to come behind us to fill these valleys, so they're just left like this. And then, so this is a perfect place for the geologists to go and find different things and study how the Earth was formed. I mean, Antarctica was not always in the South Pole. You know, millions and millions and millions of years ago, it was much farther north, tropical actually. I actually have fossils, and I wish I could have shown them to you, of ferns.
Well, you always come back.
Yes, I can. I'll bring them with me. I have ferns. I have actually a fossilized tree.
Oh, really?
Oh yeah. I have a sedimentary rock with different little plants in it. It's incredible the stuff that you find there and that were given to us by the scientists. And they all found them out here in different areas of the dry valleys. So that's why these are of such importance. We NASA has come down there with their buggies, you know, their rovers for Mars, and tested them out because it's the climate that is most similar to Mars here on Earth.
But Richard, I thought you couldn't bring these things.
If it's given to you by a scientist, you can.
You just can't.
You just can't go as a private person and say, I want this. No.
Okay.
But if a scientist gives it to you, yeah. That's the trick.
Do they do any mining to see what else is down underneath the ground?
They do drilling, but not actually, I mean, I don't know about in the actual dirt, I'm sure they do. They do cores. But most of the cores that I've heard about are what they call ice cores. And they'll go into the glaciers and they'll drill literally hundreds of meters down. And of course, the further down you go, the further back in time you go.
Yeah.
And they do that, and what they'll do is they'll take these long cores and they'll cut them in little thin slices and they'll put them in some kind of a machine that actually, that melts the ice and captures the gases that are in there, and they're able to say, oh, at this time in history, the atmosphere contained this gas at this percentage, you know? So that's how they can tell you, oh, in whatever time, how many millions of years ago, the atmosphere was like this and the temperature was like this, because they can prove it with these gases, okay? But the cores you're talking about, I've never seen those, but I'm pretty sure they do them, yeah. Okay, so this is the New Zealand base, and it's neat because it's a relatively big base as well. They have about 50 to 100 people in the summer and maybe about 15 people in the winter. And McMurdo has about 1,000 in the summer and maybe about 100, 150 in the winter, okay? But the cool thing about this photo is right here, all this, okay? And you can see the Mount Erebus, okay? And it's really cool because that ice shelf that I was talking about earlier, the Ross Sea ice shelf, it's that floating glacier we're looking at, that stops right here. So what happens is we have the island here and the glacier here. And the glacier is about the size, I guess, of 3 states or more. In the United States, 3 or 4 states. It's that big, it's huge. And if you can imagine all that force butting up against the island, okay? So all that is just pushing against the island here. So it has no place to go. And it's like if you take a rug and you just push it up, it's going to bundle up like that, right? Same thing. So we call those pressure ridges. And of course, lots of crevasses.
Yeah.
Lots of crevasses. We have just crevasses everywhere. And there's our volcano.
Beautiful.
And it's about 13,000 feet, that one is. And here's just kind of a quick shot of the top of the volcano. And that is my presentation.
Oh, that's wonderful. Thank you so much.